Here are some examples. Let's start with the two-player general sum game. We have player 1 and player 2. What can we say about this game in coalitional form? Well, there are only 4 possible coalitions. And we already know that the value for the empty set is 0. That's always going to be the case. Let's jump to the value for the set of both players. Here I'll just call them 1 and 2 using the Roman numerals, as we often do for two-player games. What's the value for the what we'll call the grand coalition, the coalition of all the players put together, in this case just the two players, 1 and 2? Well, that would be the largest total return that they can achieve. And you can see that that would be at this point 5-1, where player 1 plays row 1 and player 2 plays column 2. That's the largest total payout they can get. So we'll say the value of the grand coalition here is 6. They can't do better than that. Here are the interesting questions. What is the value for, say, just player 1? Well, our definition here for the value of the coalition coincides with our definition for of the safety level for player 1. This value for the coalition containing just player 1 is the largest amount that player 1 can guarantee himself to receive, regardless of player 2's behavior. Well, we can look just at player 1's game, A, which is the game 1-0-5-2. Here we're thinking about this as a two-player zero-sum game from player 1's perspective. And you can see very easily here there's a saddle point at this 1. Player 1 can guarantee at least 1 as a return just by playing row 1. Player 1 certainly can't guarantee any more than that. So the value for player 1 by himself is just 1. What is the value for player 2 just playing by herself? Well, here's player 2's game. Using these second components here, that would be 3-1-1-3. It's pretty easy to see that in this game B, or what we really should do is look at B transpose, but that's identical here, 3-1-1-3. Looking at B transpose for player 2 and thinking of the value for the optimal strategies and value for the row player here, the value is easily seen to be 2, and the optimal strategies are play row 1 half the time and row 2 half the time, which corresponds for player 2 to playing column 1 1/2 the time and column 2 1/2 the time. The value is just 2. So player 2, or this coalition consisting only of player 2, can guarantee at least an expected return of 2 just by playing this particular optimal strategy. So here we have all the information for the value of each coalition. Without any players, 0. 2 players together can get 6. Player 1 by himself gets 1, and player 2 by herself can just guarantee 2 or more, and all of these are or more. You see in this case, certainly the value for the coalition of 1 and 2 together is substantially higher than the values for the individual players, or even than the sum of the 2 individual players. Now let's consider a different game, where let's say you have 3 players, we'll just call them players 1, 2, and 3, who find a pot of gold worth $4 million. Any 2 of them can cut the other one out entirely. They can take the gold and leave the other one with nothing. What is the characteristic function for the game that we have here? Well, our players, remember, are just 1, 2, and 3. The value of the empty set, again, if nobody's playing, nobody gets the gold, is 0. The value for the entire group of people will certainly be $4 million. But what are the values for smaller coalitions? Well, any one player by him or herself cannot guarantee anything better than 0, because the other players could always just work together, take the gold away, and that player gets nothing. So the value for the coalition consisting of just player 1, or just player 2, or just player 3 is 0. But any two of them together can get the entire pot, the $4 million worth. So here we have all of the 8, for all of the 8 coalitions, the value for that coalition. It's always either 0 or the entire $4 million. Let's look now at a very different sort of game, the one that you saw on the first midterm as the bonus question. We'll assume 72 students, because I'm recording this before I see exactly how many papers are handed in. I'm expecting 72. And remember, in this game, a player can either check a box or not check a box. If a player leaves the box empty, the return is 0 for that player. If a player checks the box, the return for that player was 1/5 times 40 minus n. And I'll just put brackets here. And here I don't mean the standard thing for brackets, so I'll indicate this. This means round to the nearest integer. Now there are 72, with 72 students, we have 2 to the 72nd power coalitions, so I will not be listing the value for every possible coalition of students, but of course, I'll list some of the interesting ones. Well, and this might not be considered one of the interesting ones, but the value, should always remember the value for the empty set is 0. What's the value if we have for just a single student? Is there any amount, or what is the largest amount that a single student, here our students will be called 1, 2, up to 72. What's the value for just the single student, student number 1? Well, student number 1 cannot guarantee any positive value, because if 40 players check the box, 40 other players, there's nothing that student can do to get a positive number. The student can definitely get a 0 by just not checking the box. So the value for any one student is 0. And this will be true for any student. So I should say the value for a coalition S will be 0 if the size of that coalition is 1. But of course, the same argument will be true if the size of the coalition is 2. You could just have 40 other students check the box, and then there's no way that this entire coalition of 2 students can get any positive amount. It'll be the same if the size of the coalition is 3. What if the size of the coalition is 32, for example? Well, then there's still 40 other students. If they all check the box, nobody gets a positive amount for the bonus. So the value of a coalition, any coalition that has up to 32 students, is still 0. There's no way they can do anything together to get any positive amount. And I should have stressed this at the beginning of this analysis. I'm talking about the value of coalitions here, and this is if the coalition, these are all assuming the coalition can get together and decide how they'll behave as a coalition. This, of course, is very different from the rules on a midterm, where the decisions are all made individually. But now let's pretend even that the students within the coalition could get together. If there are 32 of them, they still can't guarantee any positive number. Even if there are 33, that's true, because the other 39 students, for example, could all check the box, and then in order to get anything different from 0, at least one student would have to check the box, and that would make 40, and then the payout would be 0. And in fact, because of this rounding to an integer, we'd have the same result for 34 or even 35. Imagine 35 students here. There are 37 others. If the 37 others all check the box, then what can these 35 students together do? Well, if nobody checks the box, they get 0. So let's say one tries to check a box. Then all of a sudden you have 38 students checking a box, and this number 40 minus 38 is 2, and 2/5 rounded will round down to 0. So they still get nothing. I claim the value of S is positive, and we'll see what, if the size of S equals 36. So what happens if we have 36 students together? Well, maybe under the worst conditions, the other 36 students all check the box, and then we could have one of the students here from our coalition check the box and make sure all the others don't check the box, and then we'll have 40 minus 37 over 5, which is 3/5. That rounds up to 1, and the value of the coalition is 1. So if 36 students got together and all decided to play in the manner where they have just one person check a box and none of the others do, then they can guarantee at least a single point to be earned for this entire coalition. Now, you'll see that for 37, you'll still be able to get a maximum of, in that case, we could actually get 2 points, because we could have 2 people check the box and get a point each. And you could compute the value for different numbers of players. Here's a question. What's the value of the grand coalition, all the students working together? If all the students work together among the entire 72 students, what's the largest number of points they could achieve? Well, we would want to maximize this quantity, 1/5 times 40 minus n, among all of the students who actually check the box. In other words, we want to maximize over all possible n could be any number from 1 to 72, n is the number of students who check the box. This quantity, 1/5 times 40 minus n, and remember these brackets here mean round to the nearest integer for us in this particular case, and we'd multiply that by n because we'd have n students getting exactly that amount. Well, it's a bit tricky because of this rounding function. If there were no rounding, you could ask a very much simpler question. What's the maximum for all possible x's of 1/5 times 40 minus x times x? And that, of course, is a simple quadratic function, and this is a trivial Calc 1 problem. You'd see that this maximum occurs when x equals 20, and that maximum value, when you plug in x equals 20, you'd get 20 times 20 over 5, 400 over 5. You would get exactly 80. And so we'll get a similar answer here. If we have exactly 20 students check the box, then each of those 20 students would receive exactly 4 points, and 80 total bonus points would be given away. Now, it turns out because of this rounding function, one can do a little bit better. If you increase n to 22, 40 minus 22 is 18, and 18 over 5 is 3.6, which rounds up to 4. So they would still get exactly 4 units, even if we had n equals 22. So it turns out that this maximum isn't 80, but you can get all the way up to 88, again, just because of the rounding. So it turns out in this particular problem, the value of the entire coalition, if the whole class, the 2 sections, all worked together and said, we want to do whatever will give the maximum total number of bonus points, they would have 22 students check the box. Each would get 4 points, and the total number of bonus points given away would be 88. Now remember, one of our main assumptions for talking about games in coalitional form is that utility is transferable. Well, here, at least in the way it's normally it's presented here as bonus points on exam, that utility is not transferable. Also, the coalitions can't speak to each other in the actual play of the game on the midterm. But if they could speak to each other, you would get a total of 88 bonus points, the largest possible, using this strategy for the coalition. And to kind of make up for the transferable utility situation, we'll assume that there's some sort of side payment that would make up for that people who got bonus points would pay to those who didn't, to make their total, the utility, for example, even if we wanted to do that among all the members of the coalition.